In this section, we will discuss right triangle trigonometry. So to begin, when you're given a right triangle, you have a 90-degree angle. And the side opposite the 90-degree angle is always called the hypotenuse. Now, depending on where you place your other angle that we're going to call theta, you will have a side called the opposite side and the adjacent side. So if you look in our first picture here, theta is placed in the bottom corner. So the opposite side is the vertical side. The adjacent side is the horizontal side. Now, in the second picture, we have moved our theta to the top corner. So the opposite and the adjacent sides have changed places. The hypotenuse will always be across from the 90-degree angle. Now, our trig functions are defined using the sides of the triangle. So our three main trig functions are sine, cosine, and tangent. And these are represented using sin for sine, cos for cosine, and tan for tangent. So sine theta can be found using the ratio opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. And one way to remember this is SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now, each of these three trig functions have reciprocal functions. These reciprocal functions are cosecant, represented by CSC, secant, which is represented by SEC, and cotangent, which we represent by COT. Now, the reciprocal of sine theta is cosecant theta. So the reciprocal means that you flip it over. So if sine theta is opposite over hypotenuse, cosecant theta is hypotenuse over opposite, or 1 over sine theta. Cosine theta's reciprocal function is secant theta. So because cosine is adjacent over hypotenuse, secant theta is hypotenuse over adjacent, or 1 over cosine theta. Tangent theta's reciprocal function is cotangent theta. So tangent opposite over adjacent means that cotangent theta is adjacent over opposite, or 1 over cotangent theta. Another important thing that we're going to need to use in this section is the Pythagorean theorem, and this tells us a relationship between the sides of the triangle. It says that the opposite squared plus the adjacent squared is the hypotenuse squared. Or you may have seen this written as a squared plus b squared equals c squared. For example 1, we're going to evaluate the 6 trigonometric functions of the acute angle theta given the triangle. So here we see that we're given the adjacent side length of 2 and the hypotenuse length of 5. So the first thing we're going to do is we're going to find the missing side using Pythagorean theorem. And the side that we're missing is the opposite. So we're going to use O squared plus A squared equals H squared. So filling in our A being 2 and our H being 5, we have O squared plus 2 squared is 5 squared. So opposite squared plus 4 is 25, gives me O squared is 21. So the opposite side would have length root 21 or negative root 21, but we won't use a negative for the length of the side of the triangle. So the opposite side is root 21, and that allows us to fill out all 3 sides of our triangle. Now we can apply our ratios to find the trigonometric function values. Remember our SOHCAHTOA. Sine theta is opposite over hypotenuse. So from the theta, because it's in the lower corner here, the opposite side is root 21. The hypotenuse is 5. So sine theta is root 21 over 5. Well, if we know sine theta, we automatically know its reciprocal function, cosecant theta. So cosecant theta, or CSC theta, is 5 over root 21. But that is not simplified. We want to make sure that we rationalize this so we get that radical out of the denominator. So we're going to multiply the top and bottom by root 21, and that gives us 5 root 21 over 21. Cosine theta is adjacent over hypotenuse. The adjacent side of this particular triangle with that theta in the lower corner is 2. The hypotenuse is 5. So cosine theta is 2 over 5, which means its reciprocal function, secant theta, is 5 over 2. TOA gives us the formula for tangent. Tangent theta is opposite over adjacent. The opposite side in this triangle is root 21. The adjacent is 2. So root 21 over 2 is tangent theta. Its reciprocal function, cotangent theta, we just flip that over. So cotangent theta is 2 over root 21, but that is not in simplest form. We need to rationalize it. So we multiply the top and bottom by root 21 to get a cotangent value of 2 root 21 over 21. So those are the 6 trig function values of theta for this particular triangle. For this example, we're given that cosine theta is 9 over 41, and we're asked to find the other 5 trig function values. So let's think about what cosine theta tells us. We know that cosine theta is 9 over 41, and that cosine theta is adjacent over hypotenuse. So this tells us that the adjacent side of the triangle is 9 and the hypotenuse side is 41. So I can find the opposite side and fill out my triangle. So we're going to use Pythagorean theorem to find the opposite side. So O squared plus 9 squared is 41 squared, gives us O squared plus 81 is 1681. So O squared is 1600. Now the square root of 1600 gives us 40. We will not use negative 40 for the length. So in this triangle, I put my theta in the top corner, so that made the horizontal side the opposite, which is 40, the vertical side the adjacent, which is 9, and the hypotenuse across from the 90-degree angle is 41. Now, because I know cosine theta, I automatically know its reciprocal function, secant theta, which is 41 over 9. So let's find the other 4. Sine theta is opposite over hypotenuse, or 40 over 41. Its reciprocal function is cosecant theta, so I just flip that over. So cosecant theta is 41 over 40. Tangent theta is opposite over adjacent. So the opposite side of theta is 40. The adjacent side is 9. So tangent theta is 40 over 9, which makes cotangent theta 9 over 40. So that is my answer. In this example, we're given that sine theta is 20 over 29 and cosine theta is 21 over 29, and asked to find the other 4 trig function values. Well, since sine theta is opposite over hypotenuse, I know that the opposite side is 20 and the hypotenuse is 29. Cosine theta is adjacent over hypotenuse. So I know that adjacent side is 21. So I actually know all three sides of my triangle. So for this triangle, I put my theta in the lower corner. So the vertical side is 20, the opposite. The adjacent side is 21, and that's the horizontal side. And the hypotenuse is always across from the 90-degree angle, and that is a measure of 29. Now, since sine theta is 20 over 29, its reciprocal, cosecant theta, is 29 over 20. Since cosine theta is 21 over 29, its reciprocal, secant theta, is 29 over 21. We just flipped that over. Tangent theta is opposite over adjacent. So the side opposite theta here is 20, adjacent is 21. So tangent theta is 20 over 21, which makes cotangent theta 21 over 20. So those are the other four trig function values. Now we're going to look at two very special triangles that are actually called the special right triangles. One of these triangles is called the 45-45-90 triangle. So here we have our 90-degree angle, and the other two angles are represented by 45 degrees. Notice that my two side lengths are 1 and 1, and the hypotenuse length is root 2. Now 45 degrees is the same as pi over 4. So this could also be the pi over 4, pi over 4, pi over 2 right triangle if we're thinking about it in terms of radians. The other special right triangle is 30, 60, 90. Now 30 is the same thing as pi over 6, 60 is pi over 3, and 90 is pi over 2. So this is also the pi over 6, pi over 3, pi over 2 triangle. Across from the 30-degree angle, we have a side length 1. Across from 60, we have side length root 3, and the hypotenuse has side length 2. So we're going to use the special right triangles to evaluate. Number 1, find sine of 30 degrees. So we're going to use the 30, 60, 90 triangle and the fact that sine is opposite over hypotenuse. So opposite 30 is 1 and the hypotenuse is 2. So sine of 30 is 1/2. Next, let's find cosine of pi over 4. Pi over 4 is the same thing as 45 degrees. So technically in my 45, 45, 90 triangle, I could use either 45-degree angle. So I'm just going to use the top one. So adjacent to that one is 1 and the hypotenuse is root 2. So adjacent over hypotenuse is 1 over root 2, but that is not rationalized. So we will multiply the top and bottom by root 2 to get that cosine of pi over 4 is root 2 over 2. Tangent of pi over 6. Pi over 6 is 30 degrees. So we're going to use the 30, 60, 90 triangle. And remember that tangent is opposite over adjacent. So if we go to pi over 6 or 30 degrees, opposite would be 1, adjacent would be root 3. But that is not in simplest form. We're going to have to rationalize it. So we have 1 over root 3 times root 3 over root 3 equals root 3 divided by 3. So tangent of pi over 6 is root 3 over 3. Now let's look at some of the reciprocal functions. Consider cosecant of 60 degrees. Now cosecant is the reciprocal function of sine. So we're going to find sine of 60 degrees, and then we're going to flip that over. So remember, sine is opposite over hypotenuse. So if we go to 60 degrees in our 30, 60, 90 triangle, the side opposite 60 is root 3. The hypotenuse is 2. So sine 60 is root 3 over 2. So we're going to flip that over to get cosecant. So we have 2 over root 3, and when I rationalize that by multiplying the top and bottom by root 3, I get 2 root 3 over 3. Example 5, secant of pi over 3. Well, pi over 3 is 60 degrees. So first we're going to find cosine, and then we're going to flip it over. So cosine of pi over 3 is adjacent over hypotenuse. So the side adjacent to pi over 3, or 60 degrees, is 1. The hypotenuse is 2. So we're going to take that cosine pi over 3 equals 1/2, and we're going to flip that 1/2 over to get 2 over 1, which is 2. So secant of pi over 3 is 2. Now let's look at cotangent of 45 degrees. We're going to find tangent, and we're going to flip it over. So if we go to the 45, 45, 90 triangle, I can use either 45 degree angle that I want. I'm going to use the bottom one this time. So remember, tangent is opposite over adjacent. So opposite the 45, I have 1. Adjacent, I have 1. So if I flip 1 over 1 over, I still get 1. So cotangent 45 is 1. Now let's consider this application problem. The shadow of a vertical tower is 66 feet long when the angle of elevation of the sun is 35 degrees. Find the height of the tower. First, let's draw a picture. The vertical side represents the tower. The shadow is cast along the ground, so the horizontal length is 66 feet. Now, the angle of elevation of the sun is 35 degrees, so that's going to represent the lower angle here. So we're talking about the angle from the tip of the shadow to the top of the tower. Now, I want to find the height of the tower, so I'm going to put an X on that vertical side. Because I do not know two sides of the triangle, I cannot use Pythagorean theorem. So instead I have to think, which trig function can I use to solve this problem? So I have an angle. I want to know the opposite side length. I have the adjacent side length. So of sine, cosine, and tangent, the only one that deals with both opposite and adjacent is tangent. So we're going to use tangent theta equals opposite over adjacent. So we have tangent of 35 is x over 66. If I want to solve for x, I should just multiply both sides by 66 to get the exact value of 66 tangent 35 degrees. And if I want to calculate this, I could put my scientific calculator in degree mode, and I would get 46.2 feet. So the height of the tower is approximately 46.2 feet.